I'm going to start with question 1b. You're given the reagents in 1a, so I'm going to draw out my 1-bromobutane. It's butane. Oh, wait, pen. It's butane, so I have got 4 carbons, 1, 2, 3, 4, and I have got a bromine, and I'm going to have a delta positive charge on my carbon and a delta negative charge on my halogen. The delta positive charge on your carbon, that shows you your carbon is going to act as your electrophile. They've already told you in question 1a what your nucleophile is. It is a CH3 with an oxygen with a negative charge, which is a methoxide ion. When I am drawing this, I'm going to start my arrow either at the negative charge on the oxygen, or I can draw in a lone pair on that oxygen. Don't have to draw the lone pair, you just have to make sure that your arrow is starting from the lone pair or the negative charge. I'm going to use the negative charge, I'm going to draw it from the negative charge to my carbon. That means a new bond is going to form between oxygen and carbon, which means the original bond between carbon and bromine is going to break. To show that it's breaking, I'm going to start my arrow in the middle of my bond, and it's going to end on the bromine. Okay, all of this is 2 marks. To get your 3rd mark, you need to draw the correct product. So I'm going to draw my 4 carbons again. They're untouched, but this carbon-bromine bond has broken, and instead you've now got that carbon bonded to an oxygen, and that oxygen is bonded to a CH3. You have also kicked off the bromine, and the bromine leaves with both electrons, which means it leaves with a negative charge. So all of that is 3 marks. If you scroll down to part 1D, they ask you for something similar. You're using 1-bromobutane and you're using a slightly different ion, so you don't need any mechanism, but underneath here I'm just going to draw my 1-bromobutane again, okay, and remind myself that it's that carbon that's going to be attacked. And I've got my nucleophile, it's a different nucleophile. Okay, I've got my negative charge on my nucleophile. That oxygen is going to attack that carbon, and it's going to cause this bond to break. Now, you're not required to show any of this, but for me, it helps me see what my product is going to be, because I can see what bond is breaking and what new bond is forming, so I can then draw out my product. So when I'm drawing my product, I'm drawing the 4 carbons that I always had, 1, 2, 3, and 4. This carbon is no longer bonded to bromine. It is now bonded to an oxygen, and that oxygen is bonded to a carbon, which is double bonded to an oxygen and single bonded to a CH3, okay? And that's going to be your product. If I scroll down to question number 2a, I'm just going to go through this one really quickly, okay? These flowcharts are really, really common. It's really important that you can practice as many of them as possible. You're starting off with an alkene and you're ending up with a diol, so there's 2 alcohol groups, and they're asking you for the intermediate to get from this alkene to this diol. Okay, now we've gone from alkenes to alcohols before by just adding steam and an acid catalyst. But when we do it that way, we're only adding 1 OH group to the double bond. We are not adding 2. For that reason, you're going through an intermediate to get down here to the diol. And what you're going to have to use is you're going to have to use one of your halogens. Okay, so I'm going to use, Br2, but you could also use Cl2, and if I use bromine and no catalyst is required for this, what's going to happen is you're going to get an addition reaction, and you're going to add a bromine atom to each of the carbons of the double bond. You're going to lose the double bond because it's an addition reaction. Everything else is going to stay the same, so that CH3 will still be there, that CH3 will still be there, and you are going to be adding bromines to both carbons, okay? With that as your intermediate, you can then react this with potassium hydroxide. The OH group is going to act as a nucleophile. It can attack this carbon, kick off the bromine and put an OH. And similarly with this carbon, the OH minus will attack the carbon, kick off the bromine and put it in an OH, which will give you your end product down here. I'm going to skim through all of this, but if you have problems with it, let me know. I'm going to focus on part D, which is the 6-mark question, okay? This is a really, really nice 6-mark question. All of it is already in your notes, okay? It's just important to know what's required. They specifically ask you for a suitable agent, as expected. They specifically ask you for the different reaction conditions. They want to know observations. They want an equation. And when you're using your equation, they want you to use structural formula. So they've given you kind of quite a descriptive brief of exactly what they want. You just need to make sure that you're fulfilling each one of the criteria. So I'm going to start off with so you're starting off with propan 1-ol. I'm just going to draw it out for myself just so I can see what I'm dealing with. I've got 3 carbons, and on the first carbon, I've got an OH group. So what I've got is I've got a primary alcohol, and I know if I oxidize a primary alcohol, I'm going to get an aldehyde. And if I oxidize it further, I'm going to get a carboxylic acid. This is just me jotting things down so I know where I'm going, but I'm going to now structure a full answer. So if I want to go from a primary alcohol to an aldehyde, what reagent am I going to use? So I'm going to write down, I'm going to write this in bullet points, okay? I'm going to write oxidize my propan 1-ol with potassium dichromate. And I'm going to write the name of the acid, H2SO4. You don't need to write H2SO4, you could pick a different acid, but you have got to mention acid. On the mark scheme, it said that a lot of people lost marks because they said potassium dichromate, but they didn't mention that it was acidified. So please mention that it is acidified. They want to know what you're going to see. Oxidized propan 1-ol with acidified potassium dichromate. You will see a color change. No, sorry, that's better. Color change from orange to green. How do we control if it's going to the aldehyde or to the carboxylic acid? They are the reaction conditions that they're talking about. So oxidized propan 1-ol with acidified potassium dichromate, you got a color change from orange to green. If you distill, you form the aldehyde. And I'm going to write an equation for that reaction. So they asked me to use structural formula. So I'm going to write CH3, CH2, CH2OH for my alcohol. They want me to just use an O in a bracket for my oxidizing agent. And then my product is going to be the aldehyde, which is going to be CH3, CH2, CHO. Make sure you're writing the aldehyde as CHO at the end. And I get a byproduct of H2O. Again, on the mark scheme, it said most people forgot the H2O. Or that they wrote the aldehyde but didn't have the CHO at the end. You can't write it as COH because it looks like it's an alcohol. When it's an aldehyde in structural formula, you have to write it as CHO. Okay? My other option, if I want to go to the carboxylic acid, if you reflux, you form the carboxylic acid. And then underneath, I'm just going to carboxylic acid. Underneath, I'm just going to write the equation for that. So I'm starting off with my alcohol again, CH3, CH2, CH2OH. I'm using my oxidizing agent, which I'm just using O in a bracket. And I'm writing my carboxylic acid in structural formula as COOH. Okay, again, you need to include this in your structural formula. Don't forget your water, okay? And this time we actually need to go back and balance this one because you can see I have got 2 oxygens on this side and I have got 3 on this side. So I need to put a 2 there so that I've written a balanced equation, okay? Most common places people drop marks, getting the structural formulas wrong, not remembering the water, not having these equations balanced. And they also said that the color change wasn't always mentioned, and that when you were talking about the reagent, you didn't mention that an acid was present. So you can just write acid or you can write acidified, okay? But make sure you've mentioned some sort of acid. Also says in the mark scheme to ignore if you've gone from the aldehyde to the carboxylic acid. So in each equation, they want you to start back from the alcohol. They don't want you to oxidize to an aldehyde and then to oxidize that aldehyde. They want you starting fresh from the alcohol each time. So that is how you're going to get 6 marks in a question like that. I'm going to scroll through these questions. If you have had problems with them, just message me and let me know. But I'm going to focus on question number 6 as my last question here for a moment. I'm just going to go through 6C. You're told that you have got pentan 2-ol, which I'm just going to draw. So it's pent. So I've got one. Where's my pen gone? It's pent. So I have got 5 carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Pentanetol. So you've got an OH on the second carbon, and they're telling you that you are going to convert it into an alkene in an elimination reaction. So what you're eliminating in these reactions is water. So if you're losing water, you're going to lose the OH, but you also need to lose a hydrogen, okay? There are 2 carbons adjacent to the carbon with the OH. If you lose a hydrogen from carbon 1, you are going to form the following alkene. Okay, you're losing this hydrogen, you're losing this OH, which leaves both of these carbons 1 bond short, so they're going to form a double bond, and you are going to form pent-1-ene. Your other option is if you were to lose the hydrogen from the second carbon, so the other carbon adjacent to the carbon with the OH, okay? If I lost this carbon, then I would end up with So I'm losing an OH from here, a hydrogen from here. Both of these carbons, 2 and 3, are now 1 bond short, so they are going to have the double bond between them, and you have formed pent-2-ene. When you've got alkenes, you also have the option of having cis and trans, or E and Z isomers. With pent-1-ene, that is not possible, because the carbon, one of the carbon of the double bond, has 2 hydrogens attached to it, and each carbon on the double bond must have 2 different substituents. So if I look over at pent-2-ene, this carbon here, carbon number 2, okay, it has a hydrogen, which I haven't drawn in, and it's got a CH3. This carbon here, carbon number 3, also has a hydrogen, and then it has this CH2-CH3 group. So it does fulfill the criteria. Each carbon of the double bond is bonded to 2 different groups, which means I can draw pent-2-ene as a cis and trans isomers. So if it's cis, I'm just going to draw it like this. There's 4 carbons, and there's that. Okay, so my hydrogens would be here, and they're now both on the same side, and this is my cis pent-2-ene. And if it was trans, the way I have it drawn here is fine for trans. Okay, the normal just zigzag skeletal formula is fine for trans. Okay, so I've got cis pent-2-ene and trans pent-2-ene. Now on the mark scheme, you do have to give these structures, you need to name them, but you also need to describe why they are formed. So you would have to mention what I've just discussed, that you can lose a hydrogen from either carbon 1 or carbon 3, which gives you pent-1-ene or pent-2-ene. You would then need to discuss that you have isomers of pent-2-ene. You can have the trans or the cis, because both carbons of the double bond have 2 different substituents attached. You do not get cis and trans isomers with pent-1-ene, because carbon number 1 of the double bond is bonded to 2 hydrogens, so it doesn't fulfill the criteria. So you do need to explain that, as well as giving the structures and the names. You can also give a reagent here. It's not on the mark scheme, but in order to dehydrate, you would use concentrated H2SO4. I would always include the reagent, even though for some reason it's not on the mark scheme. With the rest of these questions, I think they should be fairly straightforward. They are just simple ticking boxes. Question 10, you do not have to do question 10. Okay, there's lots of stuff in here that we haven't done. Tolerance reagent we haven't done yet. Optical isomers we haven't done yet. So you can completely scrap question 10 and move on to the next video for questions 11 to 20.